First and foremost, I would like to thank Department of Physics, Namchi Government College and Sikkim University to provide this platform to make this topic Bragg's law of X-ray diffraction, and provided by Dr. C.P. Khatiwar sir for the partial fulfillment of BSc third semester June to December 2020. So this video carries 25 marks or sessional B examination. Myself Nitesh Gurung, roll number 19 NS0133, and my topic is Bragg's law of X-ray diffraction. So first, what is X-ray diffraction? So X-ray diffraction is a technique used for structural determination of any crystalline substance. So X-ray diffraction is a technique used for structural determination of any crystalline substance. So X-ray diffraction is a technique used for any structural determination of any crystalline substance. So X-ray diffraction is based on this Bragg's law. So it is based on the concept of Bragg's law. So this it is based on the concept of Bragg's law, but it cannot be used for any determination of any amorphous substance. Now, for better understanding this Bragg's law, let's draw a representative diagram. This is our incident X-ray, and this is diffracted ray, and this point is O, this point is Y, and this is our distance denoted by D, and this is interplanar distance, and this is our parallel planes of crystal structure. So this is the diagram. So here two layers of crystal are present. This is layer 1 and this is layer 2. And now suppose a beam of X-ray radiation, so this is our X-ray radiation, falls on the upper layer of crystal. This is our upper layer. It falls on this upper layer of crystal with a glancing angle theta. So this is our glancing angle theta. Then the sum of this ray will be reflected by this upper layer of crystal with the same angle. That's our theta. So this angle, this glancing angle is our theta, and this angle also our theta. So this is incident X-ray. It will fall on the surface of this crystal and it will be reflected. So this is our incident ray, and this will be reflected. Suppose a beam of X-ray falls on the crystal at glancing angle theta, then the sum of these rays will be reflected reflected from the upper plate at same angle, that is theta. Suppose a beam of X-ray falls on this crystal, at the glancing angle theta, this is our glancing angle theta, then the sum of these rays will be reflected from the upper plate at same angle theta. So as per this statement, so this is our X-ray, it falling on the crystal, and this is our glancing angle theta, so glancing angle means angle between the incident ray and the crystal surface. So glancing angle means angle between the incident ray and the crystal surface. Means sum of this radiation will be reflected by this upper surface of the crystal, and angle between this upper surface and this reflected radiation will be same, that is theta. Means some of this radiation will be reflected by this upper surface of the crystal, and the angle between this upper surface and this reflected radiation will be same, that is our angle theta. So these two angle will be same, that is theta. So similarly, some other X-ray will be reflected in successive layers. For example, this is our alpha layer and this is our beta layer. So it will fall on this point. So this beta layer, it will fall on the point Y. This is our point Y of this beta layer. Then it will be reflected reflected with the same angle. So here angle will be theta, this angle will be theta, and this angle also will be theta. So if we take the exponential of this AO line, then it will be like this. Exponential of AO, it will be like this. Similarly, if we will take the exponential line of CO, then it will be like this. So this point can be named as X, this point can be named as Z. So here in this diagrammatic representation, angle between this XOY point, this XOY point will also be theta. This angle will also be theta, and the angle between this ZOY will also be theta. This ZOY will also be, these two angle will also be a theta. So here angle will be angle XOY equals to theta, and angle our ZOY equals to theta. So in this representation, distance between this AO O will be equal to distance between this BX. So these two AO and BX distance will be always equal. So here, here AO equals to BX. Similarly, here distance between CO, the distance between CO and the DZ will also be equal. So CO equals to DZ. So path difference between this AX ray and BX ray will be equal to XY, this XY plus YZ. So path difference equals to XY plus YZ. So this is equation number 1. And this path difference is defined as the integral multiple of wavelength, which is represented by n lambda. So path difference is defined as an integral multiple of wavelength, that is our n lambda. So this is equation number 2. And this path difference, so when we will compare equation number 1 and equation number 2, it will be like this: n lambda equals to xy plus yz. This is equation number 3. Now let's take the general formula for sin theta. So sin theta equals to length of perpendicular arm divided by hypotenuse. So sin theta equals to length of perpendicular arm, that is L divided by hypotenuse. Now let's take this triangle, that is our XOY. First we will take this XOY, this triangle. So triangle XOY. First we will take this triangle. So for this XOY triangle, sin theta will be sin theta equals to XY. XY is our length of perpendicular arm, that is divided by hypotenuse. Hypotenuse is OY. So sin theta equals to XY divided by OY. So when we will simplify this equation, so it can be written as XY equals to OY into sin theta. And here you can see that this OY is represented by D. This OY is represented by this D, and the D is the interplanar distance. So this equation can also be written as XY equals to D into sin theta. So this is equation number 4. Now let's take the second triangle, that is second triangle we have ZOY. We will take this triangle ZOY. Triangle ZOY. So here sin theta equals to ZY divided by OY. So it can also be written as ZY equals to OY into sin theta. And as you know, value of OY equals to D. OY equals to D. So it can also be written as ZY equals to D into sin theta. So this is our equation 5. Now in next step, we will put the value of this XY, this value of XY, this, and ZY, which can also be written as YZ into equation number 3. Here we have equation number 3, XY, n lambda equals to XY plus yz. So it will be like this, n lambda equals to d into sin theta plus d into sin theta. This is equation number 6. So value of xy equals to d into sin theta plus value of this zy. So this is equation number 6, and after simplifying we can also write this equation as n lambda equals to 2d sin theta. So this is our equation number 7, and this equation is known as Bragg's equation. So this equation number 7 is known as Bragg's equation. So, and here our n is order of diffraction. So here n equals to order of diffraction. So here order of diffraction is 2 because we have 2 layer of crystal, 1 and 2nd. We have 2 layer of crystal, and lambda equals to our wavelength. Lambda equals to wavelength of X-ray. So d equals to interplanar distance. Interplanar distance, and theta equals to our glancing angle. Theta equals to glancing angle, and angle of incident or angle of incident radiation. And the value for sin theta for various angles will be like this. Sin theta value, if 0 degree it will be 0, and 30 degree will be 1 by 2, 45 degree will be 1 by root 2, 60 degree will be root 3 by 2, and 90 degree will be 1. So value of sin theta, if 0 degree it will be 0, 30 degree it will be 1 by 2, it's 45 degree it will be 1 by root 2, it's 60 degree it will be root 3 by 2, it's 90 degree it will be 1. So this is Bragg's equation. This Bragg's equation gives the relationship between the wavelength of X-ray with interplanar distance, that is d, and theta, that is angle of reflection. So Bragg's equation gives the relationship between wavelength of X-ray, that is lambda, and second interplanar distance. Interplanar distance in crystals, that is d, and third one is angle of reflection, that is our theta. So this is our complete details about Bragg's law under X-ray diffraction. So thank you.